second part of the question, which is, what is the pH after the addition of 2 centimeters cubed of 1 mole decimeters cubed of HCl to the solution? So the first step in answering this question is to write out the reaction equation. So the reaction equation is the same as the one previously. It's just the acid plus water forms the weak base plus H3O+. Now the second step is to convert everything into moles. So first we want to find how many moles of HCl do we have. So here we have 5.0 centimeters cubed of 1 molar decimeters cubed. So we're going to convert that into moles. So the first step is to convert 2.0 centimeters cubed is equal to 0.002 decimeters cubed. So once we have that, we multiply the volume times the concentration to find a number of moles. Which will equal to 0.002 multiplied by 1.0, which of course just equals to 0.002 moles of HCl. So now HCl is a monocrotic acid, which means 1 mole of HCl is going to form 1 mole of H3O+. That's really important, so make sure you know which type of acid you're dealing with. Now the next step is to build an initial final chart. So here we have the equation, so we're just going to make a chart out of it. So we have the number of moles, and in the previous video we put down the concentration here. However, we don't have concentration now, but we're dealing with moles. So we need to make sure everything is converted back into moles. So we had 0.0218 molarity, so that's concentration. But to find the number of moles, we just multiply by the volume. And we find that it's 0.0164 moles. So now with water, it's the same thing as before. It's an aqueous solution, so we do not care about it. So I'm just going to put a 9 for it. Now the concentration of the weak base, we're going to do exactly the same thing as for the acid. We multiply the concentration that we found previously, multiply by the volume, and we find this equals to 0.0139 moles. Now H3O+ we do not write down because that's what we're trying to find. So now for the change. Because we're adding an acid, we're adding 0.002 moles of HCl. We're going to increase the concentration of H3O+. So we're going to write plus 0.002 moles. Now, how the buffer works is that when you add an acid, it's going to be, as you add H3O+, it's going to react with the weak base to form back into the acid. So the more of the acid the H3O+ we add, the more of the weak base it's going to react with. So we're going to have less base in the end. So minus 0.002 moles. And as that weak base is forming the acid, we're going to add 0.002 moles here. Now, since this H3O plus has reacted with the base, we're going to cancel it out, so there won't be any of it left. So it's going to be minus 0.002, which actually comes out to 0, so it's perfect. Now, the next step is to find what is the final concentration, because we have moles, we have the initial number of moles, and we have the change. So now we can just add those two, well, subtract and here add those two, and we'll have 0.0184 moles for this example. And for the other one, we're going to have 0.0139 minus 0.002, which is going to come out to 0.119. This one comes out to 0. Well, more or less 0, we say. So now we have the number of moles, and we want to find the concentration because we're going to plug it back into the Henderson-Hasselbalch equation, which, as you can see, has concentration. So we have the number of moles, and we want to find the concentration. So we just divide by the volume. However, now the volume is actually bigger because we added 2 centimeters cubed of HCl. So we just add that up. So instead of having 0.750 liters, we're going to have 0.752 liters. Now, the next step is just to plug it back into the Henderson-Hasselbalch equation. Remember that the pKa, we already found that out in the previous video. It was 4.2. So plus the log of the conjugated base over the weak acid. Now, if you remember your math skills, when you divide two fractions which have the same denominators, you can just cancel them out. So that's what I'm going to do because it's easier. So I'm going to put the conjugated base, which is C6H5COO minus, over the acid. And this, I already calculated, comes out to 4.01. Now the last step is that you need to check. It's really important to do that because the whole point of a buffer is that when you add a small amount of an acid or a base, the pH should not change much. And we found in the previous video that the pH was 4.1. And here, even though we added some HCl to it, the pH is 4.01, which is still close, so that's very good. Alright, thank you for watching and good luck for your exam.